Imagine being cuddled up in a cozy blanket, watching the snowflakes fall outside your window, when suddenly a blizzard hits. But have you ever wondered how these blizzards form? In the grand ballet of our atmosphere, two main dancers take the stage: cold air and moisture. These two elements are the key ingredients in the formation of a blizzard. Let's take a closer look at this fascinating process. It all begins when cold air, which is heavy and dense, settles close to the ground. Now, over this cold air layer, imagine warm air blowing in. This warm air is lighter, and it rises above the cold air, creating a kind of atmospheric sandwich. As this warm air ascends, it creates a low-pressure system. In this low-pressure system, winds begin to swirl in a circular pattern. This is due to the Coriolis effect, a phenomenon caused by the Earth's rotation, which makes winds veer to the right in the northern hemisphere and to the left in the southern hemisphere. But what about the snow? Well, that's where our second dancer, moisture, takes the spotlight. The warm air carries moisture, which is drawn up into the cooler regions of the atmosphere. As this moisture cools, it condenses and forms tiny ice crystals, which we see as snowflakes. When these swirling winds reach a certain speed, about 35 miles per hour or more, the falling snow is swept up, reducing visibility and creating what we know as a blizzard. The dance of the warm and cold air, the swirling winds and the freezing moisture all come together in a spectacular, albeit sometimes disruptive, winter performance. So next time a blizzard strikes, remember the dance of warm and cold air that's causing all that snow. It's a complex, fascinating process that transforms our world into a winter wonderland. Snowflakes, beautiful and unique. But have you ever stopped to think about how they are formed? Well, the journey of a snowflake begins way up high in the atmosphere where the air is cold and full of moisture. This moisture, or water vapor, is the key ingredient in the formation of snowflakes. You see, when the temperature drops below freezing, these water vapor molecules start to slow down and stick together, forming ice crystals. The shape of these crystals is determined by the temperature and humidity at which they form. The colder and drier the air, the simpler the shape of the crystal. Higher humidity and slightly warmer temperatures can lead to more complex and ornate shapes. But a single crystal isn't a snowflake just yet. As the ice crystal falls through the clouds, it may encounter more water vapor. This additional vapor also freezes, sticking onto the original crystal and causing it to grow. As the crystal continues to fall, it bumps into other crystals and they stick together. This process continues until the ice crystal, now a group of many ice crystals, becomes a snowflake. And here's the thing, each snowflake's journey is unique. They each travel through different air currents, encounter different levels of moisture, and stick to different ice crystals. That's why no two snowflakes are exactly alike. The final step of the journey happens when the snowflake becomes heavy enough to fall to the ground. This happens when the snowflake's mass is greater than the updrafts of air that have been keeping it afloat. So, while it might seem like magic, the formation of a snowflake is really a fascinating journey through changing temperatures, colliding ice crystals, and finally, a graceful descent to the ground. So, each snowflake is a little bundle of ice crystals, each one as unique as you and me. A winter wonderland is incomplete without a blanket of snow. But why does snow stick to the ground sometimes and not others? Well, let's dive into this frosty mystery. The key factor determining whether snow sticks or not is the temperature of the ground. If you've ever tried to build a snowman on a sunny day, you've probably noticed that the snow melts pretty quickly, right? That's because for snow to stick, the ground temperature must be at or below freezing. You see, snowflakes are delicate structures, each one a tiny masterpiece of ice crystals. When they fall from the sky and land on a surface that's warmer than freezing point, they simply can't hold their form. The heat from the ground causes the snowflakes to melt, transforming them from their unique crystalline structure into plain old water. But when the ground is at or below freezing, it's a whole different story. The snowflakes maintain their form upon landing, creating a layer of snow on the ground. And as more and more snowflakes fall and stick, they form a blanket of snow. That's why on some days, you'll see snow covering every inch of the landscape, from the tallest trees to the smallest blades of grass. Now, you might be wondering, what about when it's snowing, but the ground isn't freezing cold? Well, initially the snow might melt as soon as it hits the ground. But if the snowfall is heavy enough and it keeps coming down, it can actually cool the ground. This creates a cold layer where the snow can start to accumulate, even if the ground was initially above freezing. So, the next time you're hoping for a snow day, keep an eye not just on the sky, but also on the ground temperature. It's not enough for it to be cold enough for snow to fall. If you want a winter wonderland, you need the ground to be cold enough for the snow to stick. So, a white Christmas depends not just on the snowfall but also on the ground temperature. Freezing rain, a winter hazard that turns everything into a skating rink. But how does it form? Well, let's dive into the science behind it. Firstly, it's important to understand that freezing rain is a product of a unique atmospheric setup. Picture this: a sandwich of air layers with a warm layer nestled between two cold ones. This situation is known as a temperature inversion. It's the key ingredient for the formation of freezing rain. In this setup, snowflakes begin their journey in the upper cold layer, where the temperature is below freezing. As they fall, they pass through the warm layer and melt into raindrops. Now, here's where the magic happens. These raindrops continue to fall, entering the second cold layer near the ground. However, this lower cold layer is so thin that the raindrops don't have enough time to refreeze into sleet or snow. The result? These supercooled raindrops remain in a liquid state until they make contact with the surface, which is at or below freezing. Upon contact, they freeze instantly, creating a glaze of ice on everything they touch. From trees and power lines to roads and sidewalks, everything gets coated in a slick, icy layer. Now you might be thinking, that sounds lovely, a world encased in ice. But remember, it's not all beauty and shimmer. Freezing rain poses a significant risk, especially for transportation. Roads become slippery, turning into potential accident zones. Pedestrians have to tread carefully to avoid slipping and falling. Power lines can become so heavy with ice that they snap, leading to power outages. So, while freezing rain can transform the world into a winter wonderland, it's essential to treat it with the respect it deserves. Be aware of weather forecasts, especially during the winter months, and take precautions when freezing rain is expected. Freezing rain may create a winter wonderland look, but remember, it's a hazard for both drivers and pedestrians. Sleet, the icy pellets that often accompany winter storms. But what causes sleet to form? Imagine a snowflake, gracefully making its descent from the sky. This snowflake, our protagonist, embarks on a journey that will transform its very essence. It first encounters a layer of warm air that envelops it like a cozy blanket. The warmth of this layer is intense enough to melt our delicate snowflake into a droplet of rain. Suddenly, our snowflake is no longer a snowflake. It's a raindrop. Now, this isn't the end of our journey. Not by a long shot. This raindrop continues to fall, and as it does, it meets a layer of freezing cold air closer to the ground. This layer is not as welcoming as the previous one. It's harsh and cold, but it brings about a change. This sudden chill refreezes our raindrop, molding it into a small pellet of ice. Thus, our snowflake-turned raindrop is now an ice pellet. And it's this transformation, this journey of a snowflake through layers of varying temperatures, that gives us sleet. You might ask, why does this happen? Why does the snowflake transform into a raindrop and then into an ice pellet? Well, it's all about the temperature profile of the atmosphere. If the warm layer is thick enough to completely melt the snowflake into a raindrop, and if there's a sufficiently cold layer beneath to refreeze that raindrop, then voila, we get sleet. However, if the warm layer isn't thick enough to completely melt the snowflake, or if the cold layer near the ground isn't cold enough to refreeze the raindrop, then we get something different. We get either snow or freezing rain. But that's a story for another day. Today, we've journeyed with a snowflake as it transformed into a raindrop and then into an ice pellet, giving us a first-hand look at the formation of sleet. So, sleet is essentially snowflakes that have had a brief identity crisis as raindrops before becoming ice pellets.